Hello, I'm Mr. Vosser and I'm a computing science teacher. I'm really looking forward to delivering this pre-recorded lesson to you where we're going to look at 2 of the 4 higher computing science units. The first unit is computer systems and the second unit is software design and development. Out of those 2 units, we're going to particularly focus on the short response questions. So these questions shouldn't take you too long. They should allow you to bank easy marks in the exam by recalling knowledge from those 2 units and maybe applying it to a scenario or being able to get it down and demonstrate your understanding. Of course, within those 2 units, in the software design and development unit in particular, there is more detailed answers that will be looked for in longer questions in the exam, especially with the coding. So you need to make sure that you also go and revise those as well. But this here is very much focused just on those short response questions. And of course, there's 2 other units that will be studied within the higher computing science course of database design and development and web design and development. So hopefully this video is just part of a package of revision that you've put together to prepare yourself for your assessment or examinations in the near future. So all that's left for me to do is say, let's get ourselves started. Hopefully the questions will really support you with your learning. If there's anything you come across though and you're not sure, do make sure you go and speak to your teacher, look for other online resources, or find a way to get help to help you understand any gaps in your knowledge. Okay, let's go. To start with, we'll want to outline the purpose of these sessions. So the learning intention is that we're learning to apply our knowledge in answering short response questions for the software design and development unit, and we're learning to apply our knowledge in answering short response questions for the computer systems unit. So short response questions have quite focused, limited answers that they're looking for, and that's information that we should be able to recall from our learning, and that will be covered through your classwork, through your homework, and through the learning that you'll have done yourself while at home. And to be successful, you'll be able to recognize that the type of question being asked and understand the style of response needed, and you're going to be able to apply your computing science knowledge to that question to ensure that you can achieve the maximum number of marks available. Okay, let's start by looking at some questions. Here are some generic tips that you could apply to any examination, but I think it's really important to think about them in terms of a computing science context as well. So make sure you take the time to read the question and understand what you're being asked to do. So quite often there is information within the question which will help you problem solve the answer. So taking the time to understand any keywords, taking the time to understand all the information that's being presented to you is absolutely essential. Make sure as you're working through these questions, you're managing your mindset. It's going to be absolutely possible that sometimes there's questions that you don't really understand or you're not completely sure what the answer is. Well, taking that time to go through that question and understand what is being asked you will hopefully mean you can use your problem-solving skills to be able to work out the answer or something pretty close to the answer where you might pick up some marks. So keeping positive and continuing to have a go is really important. Of course, you've only got a limited amount of time in your assessment or your examination time, and making all of that time count is really important. Either spending the time methodically going through the paper and keeping to a time outline that you've set yourself, or using any spare time at the end to go back through your questions is absolutely critical. And finally, make sure you're keeping your answers really clear. Your teacher or the examiner will be marking your paper, and they want to be able to easily identify what is your answer and potentially how you arrived at that answer. So making sure you've used a clear structure or you've clearly identified where you've answered a question. If, for instance, you've had a go and then you've decided to have another go and make some changes and you've arrived to a different answer. You can just cross things out by putting a single line through them. The examiner will look for the answer and identify it, but just try and keep everything neat and tidy. Avoid scribbling or anything like that in the exam. Okay, let's have a little talk about what's going to happen in this video. So I'm going to present questions to you on the screen. I'll read through the question and I'll just make sure it's fully explained before I pause the video. When the video's paused, use the time to work through your answers. Once you've worked through the answer, unpause your video and then come back and see whether we've got the same answer, and I will talk you through how I worked through to get to that answer. Where there's the pause icon, there's also a suggested time about how long you should take on the question. This is a notional amount of time just to give you a bit of a guide, but I would certainly try to stick to that time as closely as possible to ensure that you're having the right pace for when you are in your assessment or examination. Starting off then, we're going to look at how we convert the following 8-bit 2's complement binary number into denary. So we've got ourselves a 2 complements binary number, and we're looking at how we can convert that into a decimal number, and that's a 11011101 that we're looking to convert. So hopefully you should be pretty familiar with your number conversions, and this is a 2's complement, so make sure that you remember that it's slightly different to just a normal binary decimal number, and you'd be looking to do this in under a couple of minutes. So pause the video now and give that a go. Okay, so the way I'd approach looking at how to solve this is by using a table method. There are other methods which you may have been shown, and that's absolutely fine. Use what works for you. But I start off by drawing out the table, and because it's a 2's complement binary number, we know that it can represent both positive and negative numbers. So the largest number that it can represent when it's 8-bit is 127, and its smallest number is negative 128. So I would start off with the table there, putting the numbers into their corresponding columns, and that would let me see that I have 1 minus 128, plus a 64, plus a 16, plus an 8, plus a 4, plus a 1. And when I complete that maths, that gives me negative 35. Now, with our 2's complement binary numbers, if the first binary number is a 1, when I look at it on the left-hand side, then that's going to indicate to me that it's a negative number. If that was a 0, that would indicate to me that it's a positive number. So I had a good feeling it was going to be a negative number. Just add all the other items up, add it to negative 128, and that's given me negative 35. If all of the numbers were 0, then the number would, of course, be 0. So that's how I'd go about solving question 1. Let's have a look at question number 2. A string variable called month has been assigned the value April, and another string variable called year has been assigned the value 2019, as shown below. And then we've got line 1, declare month, initially April. Then we've got line 2, declare year, initially 2019. And then we've got line 3, which has been left blank. The variable short date is to be assigned the value April 19 using substring operations. Using a programming language of your choice, write line 3. So we have got 2 lines of information already where some assignment has occurred. We are looking to assign more information, more data to the variable short date, and it's given us an example of what that should look like. We're going to need to use some substring operations to write that third line of code. 2-mark question, couple of minutes on this to get yourself going. Pause the video now and give that a go. So the important thing to note with the answer to this question is there is more than one way to get to the correct answer, and the code that I've used here is perfectly acceptable, but equally if you've got something that is completing the similar kind of steps, then it is likely that you'll be able to pick up the marks as well. So you're getting 1 mark for assigning the right information to short date, and the second mark for taking that information that is right and concatenating it. So that's joining 2 strings together. So I'll explain how each of those 2 stages work. So I've got short date equals, so that is the assignment to short date, which is what the question is asking us to do. And then we're trying to get the value April 19 using substring operations. So I'm kicking off by using a left function, and this is taking the first 3 characters from the left from the variable month, and then that's being concatenated. So we can see that's being joined together by using the ampersand. And then we've got the function right. That's being applied to the variable year, and it's taking the first two characters from the right, and they get joined together to give us APR 19. Now, you could have used other functions like midpoint, and that would have been acceptable. It's just a case of making sure the numbers that you've used around that and the variable names are correct. And you might always choose just to give a little short explanation to explain what your functions do if that's not really obvious and really clear to the examiner. Obviously, in this case, with left and right, you know exactly what it's trying to do. So just make sure whenever you're doing any coding question, it's going to be clear for someone who's coming to the paper and looking at your assessment, who's maybe not had your benefit of your thinking behind it. So would somebody with no prior knowledge be able to read the question and then be able to recognize it? Obviously, it's being marked by a teacher who will understand kind of programming languages and code. But if you've used something particularly fancy or something that you don't think is particularly standard, make sure you've explained what that function does to be super clear to get both marks. Okay, let's move on and have a look at question number 3. An instruction to be executed is in memory, and it's in the memory address 3412. Complete the missing steps of the fetch execute cycle shown below. This is a 2-mark question. Step 1 is there for us. The processor sets up the address bus with the address 3412. We then have nothing in for step 2, and we have nothing in for step 3. Step 4 is given to us, and step 4 says the instruction in the instruction register is then interpreted by the decoder and carried out. So we're looking to put information into step 2 and into step 3. This is a 2-mark question, so you'll want to give yourselves a couple of minutes. There should be just some knowledge recall about the fetch execute cycle, applying it to the scenario of using the memory address 3412. Let's do that now. Okay, so the information we'll be looking for in the 2 steps. Step 2, the processor activates the read line on the control bus, or it might be referred to as the control unit, and you could say the control unit activates the read line. I certainly prefer the terminology around a control unit activating the read line because that more accurately reflects what's happening in the computer. It is a control unit, and they are a series of lines which are activated, as opposed to buses where information is actually being sent along those wires. So just some thought there. Step 3, an instruction is fetched from memory, and that memory location using the data bus. And then you can say it's stored in the instruction register. But it's about getting this idea that the data is fetched from the memory location using the data bus, and it travels along there. And of course, the data bus, the information is bidirectional because it can be sent to memory and data can be got from memory, whereas the address bus is unidirectional because the information is always coming from the processor going along the address bus. So that is question 3 for your 2 marks, and you just want to be nice and clear with the steps that you've got there, and you can just learn them and then reproduce that in the exam. Turning ourselves to question number 4. Question number 4 gives us the decimal number 6.125 converted to binary is 110.001. Convert 110001 to floating point representation. There is 16 bits for the mantissa, including the sign bit, and 8 bits for the exponent. So we've been given all the information we need to be able to represent the positive number, 6.125, and that's already been converted into binary for us 110, 001. And we're just looking to now represent that in floating point. And we've been given 16 bits for the mantissa, including the sign bit, and 8 bits for the exponent. This is a 3-mark question, and you'll want to spend a little bit of time recognizing which bit will be the mantissa, recognizing which bit will be the exponent, and also what you're going to use as the sign bit. So 3 to 4 minutes to complete this question. Pause the video now and give that a go. So we're representing a positive number, 6.125 or 110.001. So when we represent positive numbers, we know that can be represented using a 0 as our sign bit. So in the sign bit, I've gone 0. If it was a negative number, my sign bit would be a 1. The mantissa will then have 15 bits left over, because out of the 16 bits, 1 bit is being used to represent the sign bit. The other 15 bits are being used to represent the mantissa. So my mantissa is 110.001, and then I've got 9 zeros after that. And this is representing the actual number itself. We then need to use the exponent to represent how many places the decimal point has moved. And the decimal point has moved 3 places. So the exponent is the number 3, written in binary, which is 00000011. And that's how we end up with all that information there. This is probably something worth going over and doing a few worked examples where you can, because it's something the more you practice and the more familiar you get with working with your mantissa and your exponent and recognizing the sign bit, the easier it gets. Question number 5 asks you to describe the role of the client when developing software using Agile methodologies. So it's a 2-mark question, and you're wanting to be able to recognize what is happening in an Agile methodology when it comes to developing software, and then be really focused on what the purpose or the role of the client is as they do that. It's a 2-mark question, so we should be able to get this information down within a couple of minutes. Pause the video now and give that a go. Okay, so the client will be detailing the requirements that they want the software to be able to do that's being developed. So their involvement with that process is absolutely key. And they will also be outlining the scope and boundaries. Now, in terms of how the detail requirements come about and how the scope and boundaries come about, that might be through observation of the current system. That might come through questionnaires or surveys or interviews with the client to make the client fully involved with those stages of development in that early analysis phase. As we move into the design phase, the client's role will continue with the early development of prototypes and the kind of looking at maybe wireframes, kind of being spoken through the types of processes that the system will do. So they have that early opportunity to suggest changes and provide feedback. And then that continual prototyping, maybe using low fidelity prototypes, and as the system develops, being fully involved with the testing, means the client at every stage has the opportunity to provide feedback, and then that feedback is taken back to the development team continually throughout the process to ensure that the changes can be made to successfully implement a solution that the client is happy with. And this might allow development to happen quicker than, say, following the traditional waterfall method, because the client and problems that the client might have with the program, which might only be discovered during testing, should get picked up far earlier because the client has had more involvement with the project. However, one of the disadvantages of this system might be, with such a heavy involvement from the client, there could be lots of tweaks or maintenance that might fall under an adaptive maintenance regime if we were looking at a more traditional waterfall method. And that could mean that actually the process ends up being slowed down. So with any sort of agile methodologies, it's all about how it's managed, and the project needs to be managed really carefully to ensure the best possible outcome. Okay, we've got the next question coming up, but before we look at that, we need to look at some code. So I'm going to talk you through the code that we have here. A shop has a unique product code for each item it sells. For example, X756. The linear search algorithm shown below is used to find the position of a product code in an array. So hopefully a linear search algorithm is a standard algorithm which you already have an awareness of, and we're just looking at that in terms of this scenario with a shop having unique product codes. So that means no two product codes should be the same, and the product code that we're going to be talking about here is X756. So let's look at the code then. Line 1, function linear search, open brackets, array of string list, and then it says returns integer. Line 2, declare position initially 0. Line 3, declare target initially, and then we've got quotation marks with nothing in them. Line 4, send enter target value to display. Line 5, receive the target from keyboard. Line 6, for index from 0 to length of list -1, do. Line 7, if target equals list, index, then. Line 8, set position to index. Line 9, end if. Line 10, end for. Line 11, return position. Line 12, end function. The array of unique product codes is shown below. And then in position 0, we have C232. In position 1, we have T546. In position 2, we have X756. In position 3, we have W482. And in position 4, we have B629. And so the list will continue. Notice how when I've spoken about the positions, we're starting at position 0 because on line 2, we declare the position initially as 0. So the first one in our list, C232, is position 0, T546 is position 1, and so on. It's really important when we're reading code and we're reading these questions that we're studying the code and we're studying the information that we've been given alongside it. So in this case, an array of unique product codes, to make sure we're understanding how the programmer who's written these questions has set up the program so that we will be able to come to the correct answer when we get to the questions. So question number 6 asks, state the value that will be returned by the function if target is X756. So you may want to go back and just have another look at that code. But hopefully with us having spoken through each of those lines of the code, you'll be able to identify the value that will be returned by the function. So 1 mark question, you should be able to just take a minute now looking over that code and identifying the answer. Pause now. So state the value that will be returned by the function if target is X756, and it is position number 2. So position 0 is C232, position 1 is T546, and position 2 is X756. So as we looked back at that function, we could see that function was providing the linear search. It was searching through looking for X756. When the target X756 matched the value in the list, the index in terms of the number of items we'd been through and checked with the for loop, when we'd got to where the match was, we'd stored that index number to position and we returned position to the user. And in this case, it was the second position that our target value was being stored in. So just take a bit of time to look over the linear search algorithms if that isn't completely comfortable with you. Now, you will have noticed that this linear search algorithm is inefficient. So question number 7 does ask, describe how the algorithm could be made more efficient. So at the moment, we can see that that was a fixed loop with an if statement in there. But there may be alternative ways to do that. This question is asking us what that could be. 1 mark, about a minute to come up with your answer there. Pause the video now. So I gave you a bit of a clue that this linear search algorithm is inefficient. And I said that's because it's using a fixed loop at the moment, which is a little bit more than you would have got in the question, but hopefully you'd have seen that from reading the code. And then it's asked you to describe how the algorithm could be made more efficient. Well, of course, you could use a conditional loop with termination. So at the moment, even if the target value was found in the very first position, it would continue running through the full loop for the rest of the list. Now, if the list has only got 5-6 items in it, that's not the be all and end all. But if the list had 5,000, 6,000 or 50,000, 60,000 items in, that's a lot of processing power that we're using on a computer for no real gain at all. So what we want to do is terminate the loop when we have a match. And so we would continue going until found equals true, or the target equals the list index number, and we've got a match there. But just for the mark here, you just need to be able to identify that you'd want to use a conditional loop with termination. And if you'd given an example of that for extra clarity, then your example would be accepted as well. So you can decide what's the best way to demonstrate your knowledge there. Okay, let's look at question number 8. The product code F333 is entered. It is not in the array. State the value returned by the function. State the type of error this is, and explain your answer. Now, this is a 3-mark question because there's 3 elements to it. You're having to state the value returned by the function, state the type of error, and also provide an explanation of why it is that type of error. Being 3 marks, I'd give yourself around about 3 minutes to be able to get all 3 pieces of information down. Pause the video and give that a go now. So the first part of this question is asking us to state the value returned by the function. And we've used the product code F333, and it's an item that's not in the array. So if we cast our minds back to the code that was set up for the shop and look at line 2 in particular, it says declare position initially as 0. And it's the position that is the value that is being returned. So that variable, we need to see if it's being updated at any point by the code. And we can see that because F333 isn't located within the code, then that position value isn't going to change, which means the value that's going to be returned by the function will be 0. Now, obviously, position 0 isn't the correct answer. So at position 0, there is already another value, and that value is C232. So by returning position 0, it's an error in the programming code. So the second part of the question there is asking to state the type of error and then to explain your answer. Well, when the programming code works, but it provides the wrong value because there's been an error made in the logic of the code, that is a logic error. So for the first mark, we're saying the value is being returned is 0. For the second mark, we're saying the error is a logic error. And then we need to explain to be able to get that third mark. And your explanation is just a case of summarizing what I've just said there in terms of it returns a position for an item that is not in the list. Or you can be a bit more specific and say it returns the position of the first item in the list, which in this case is C232, not F333. And if you wanted to put, for real clarity, you could say that, the code could be changed to return product code not found or something like that. And that, I guess, is just making sure you've fully explained your thinking to the examiner using all the space that is available to show that you understand. So let's have a look at question number 9. Explain the difference between a public key and a private key when securing the transmission of data? So this is a 2-mark question and there's no context provided with it. So all you need to do is just get down what your public key is and what your private key is and how that is being used to secure data when it's being transmitted. So it's a 2-mark question. So you'll want to give yourself about 2 minutes to get this done. Pause the video now and give that a go. So we're looking to explain the difference between a public key and a private key when securing the transmission of data. Well, as we know, data that's transmitted over the internet is often very easy to intercept, and most of it is text-based. In order to keep the data secure, it needs to be encrypted when it's being sent over a network or the internet. And the process, called a cipher, is used to scramble that data so it doesn't make sense if the text is intercepted. However, of course, the cipher needs to be reversible, so the original message can be restored if you have the key to the cipher. So an encryption key specifies how the cipher is going to scramble the data and how to turn it back into the original data. To be secure, the system sending the data and the system receiving it must agree on the keys they're going to use, and no one else should know that information. So both systems need to know what the key is without transmitting the key itself, because of course, if the key itself was transmitted along with the encrypted data, then the encrypted data could become decrypted and then hacked. So we have the two keys, public and private, and these two keys are mathematically linked, and that's normally generated from really long numbers which make it very difficult to crack. So the public key is the key that's known by everybody, and it's used to encrypt messages, and the private key is known only by the recipient and is used to decrypt the messages. So, ciphers are very complex, and only the private key will be able to decrypt the message. The public key cannot be used to you can't hack that and work it backwards to work out the private key. That's not possible. So by saying that the public key is known to all systems and the private key is only known to one system, or the system being used to decrypt the personal data, then that's how you get the 2 marks, being really explicit about the purpose of that public key and the purpose of the private key when securing data in transmission. Okay, question number 10. Character sets can be represented using either ASCII or Unicode. Describe an advantage of using Unicode over ASCII, making reference to the number of bits used to represent a character in each format. So this is a 2-mark question. Being able to understand clearly the difference between Unicode and ASCII is going to get you that 1st mark. And then it's saying you need to make reference to the number of bits used to represent a character in each format. That's going to give you a clue as to where the 2nd mark is coming from. So 2-mark question, we're getting some information down about Unicode and ASCII. So please allow yourself about 2 minutes to get this done. Pause the video now and give it a go. We know when we're working with binary, we can represent numbers, we can represent graphics, and we can represent text. Everything ultimately that is on the computer has to be represented in the binary machine code for it to work. So here we're looking particularly at representing characters, and those characters, of course, can be represented in binary. And we group those characters together in what's called a character set. And each character set includes the alphanumeric data, so that's both letters and numbers, symbols like our star, our exclamation mark, our ampersand, our colon, our semicolon, as well as, of course, the control characters. So that's the shift, the escape button, the function keys along the top of your keyboard. So each of those needs to be programmed and operational by a character set. Now, both ASCII and Unicode are examples of character sets. So the first part of the question is describe an advantage of using Unicode over ASCII. Well, effectively, we've got 3 types of character sets within ASCII, or 2 within ASCII, and then Unicode, which makes our 3rd. So ASCII uses an 8-bit code to represent characters, but some people would say that ASCII is using 7 bits because when originally ASCII was first formed, it was the equivalent of 7 bits to represent 128 characters, and then the 8th bit was often used to perform a parity check, which is a form of error checking. So if you've just got regular ASCII, you've got 7 bits for ASCII to be able to represent 128 characters, and you've also got your parity check, the error checking that goes along with that. Now, if you extended that to 8 bits, so you don't do the parity check and you have something called extended ASCII, it's possible to disregard the use of that parity bit, and ASCII can then represent 256 characters. So in terms of the key information there, ASCII uses 8 bits to represent the character set. That's up to 128 characters, or up to 256 if you're using extended ASCII. ASCII is, of course, less demanding on the computer memory, takes up less space than Unicode, so that would be an advantage of ASCII over Unicode. But we don't want a advantage of ASCII over Unicode. We want an advantage of Unicode over ASCII. So, of course, ASCII and both extended ASCII, they're limited by 128 or 256 characters, and being able to represent all the characters for several different languages just is not possible in ASCII. So an advantage of Unicode is Unicode can represent more characters and better reflect the nature of communicating in an international world where many languages are spoken. So by all means, give that level of detail. But in terms of talking specifically about Unicode, well, Unicode was created to allow more characters in the character set than ASCII. Unicode using 16 bits means it can represent 65,536 characters, and Unicode uses all 16 bits to represent each character. That greater range of characters is a big advantage, and there are adapted forms of the original Unicode capable of representing even more characters than that, because as we know, some countries in the world have really quite complicated alphabet systems. So you want to say Unicode can represent more characters, and then we want to go on to say that Unicode uses the 16 bits because that's making reference to the number of bits, compared to ASCII's, and both 7 or 8 bits is accepted depending on whether you're talking about ASCII or extended ASCII, as we've got in the example there. Okay, let's turn to question number 11. Question number 11 is asking us to convert the number 116 into 8 bits 2's complement, and that's negative 116. So we're wanting to do a conversion here. So I would say you'd want to spend up to 2 minutes working on the conversion of a negative number, just to be able to make sure that you've worked it through correctly, and then working it back through to make sure you've definitely got the right answer. So pause the video and give that a go now. So when I'm converting a decimal number into 8 bits 2's complement, I always find it helpful to draw the table out so I can make sure that I'm not making any errors. Now, you may know other ways to be able to convert numbers from denary into binary, and that's absolutely fine as long as you're using a system that you're completely comfortable with. I find this table lays it out nice and neatly, and it's easy for me to kind of trace back and check each step. So I start off by finding the number 116, the positive value in 8-bit binary. And so that's 164, 132, 116, and 14. And when I add all of that up, I get 116 in the positive value. Now, I am going to now flip the bits. So my zeros become 1 and my 1s become 0. And I've written that out directly underneath just to help me make sure I've got everything lined up nice and neatly. I then need to add 1 to that value. So I would do 1 plus 1 becomes 1, 0, and just work through all the way along until I've got the value. So that's given me the value of 1, 0, 0, 0, 1, 1, 0, 0. Now that is negative 116 in 2's complement 8-bit binary, and I can check that by going with my table again, changing the first value of 128 to negative 128, because 8 bits 2's complement can represent numbers from negative 128 up to 127, and I can see I've got a 1 in negative 128, so I know it's a negative number. I've then got my 0 values for 64, 32, and 16. I'm adding 8 and 4 to negative 128, which does give me negative 116. So I've been able to work through that answer to check that it's correct. Okay, let's turn to question number 12. The increased use of cache memory is one trend that improves the performance of a modern computer architecture.
State one other trend that improves performance. Describe how your answer improves the performance. So it's a 2-mark question, 1 for stating the trend, and then 2 providing a description that relates to the trend that you've just referred to. Hopefully you've learnt about factors affecting computer system performance. 2-mark question. Give yourself a couple of minutes to get this information down. Pause the video now and give that a go. So, the increased use of cache memory is one trend that improves the performance of modern computer architecture. State one other trend that improves performance. Describe how your answer improves the performance. Well, I think one of the really nice examples that you can give here is multi-core processors. So, multi-core processors allow simultaneous execution of instructions or the ability to be able to do parallel processing. So a CPU can contain one or more processing units, and each unit is called a core. A core contains an arithmetic and logic unit, a control unit, and registers. It's common for computers to have 2, so we'd call that dual core, 4, quad core, or 6, 8, even some computers now with 12 and 16 cores that are becoming commercially available. So CPUs with multiple cores have more power to run multiple programs at the same time. However, doubling the number of cores doesn't just simply double the computer's speed, because those CPU cores have to communicate with each other, and they do that through channels, and this uses up some of the extra speed while they coordinate which processor or which core of the processor is processing what. And of course, we could improve the system performance by increasing the width of the data bus. And the data bus is a set of parallel wires that connects and transports data between the processor and the main memory. By, say, increasing the data bus from 32 bits to 64 bits, the computer can transfer twice as much information at one time. So more bits can be transferred in a single operation, thus improving the computer performance. We could look at increasing the clock speed. So the clock speed is controlled by an element of the control unit, and that would allow more fetch execute cycles per clock pulse. And that would obviously be beneficial because it would allow more data to be processed. We could also look at increasing the RAM or the memory, and this reduces the need for having, or you've got faster access than being able to access slower backing storage. So the more information you can have stored in the registers on the processor, or the more information that you can hold on cache, which is a small amount of memory, which is part of the CPU, which is close to the RAM, that's going to speed up the process. It's just used to temporarily hold instructions, and then the data can be processed and used by the CPU far quicker. And of course, saying that cache is closer to the CPU than the RAM is, or saying that RAM is faster than your stored backing storage, all of those are appropriate solutions to the problem there. And finally, we can look at the increased use of solid state drives, and solid state drives really have revolutionized computing in the last few years because their faster access means that big complex operating systems can load much faster, and we can use much bigger packages because the ability to be able to load information from that backing storage into memory has become so much faster than it ever was before.
Well, I really hope you found this session useful. We've spent the last 45 minutes looking at some top tips and some approaches that we can take when we're in the exam or assessment, so make sure you keep calm. And we've looked at short response questions for both that computer systems and software design and development unit. Do make sure though with the software design development unit that you go away and really study that in detail for the longer style questions. And of course, if anything came up that you didn't understand, make sure you're either looking online, looking in your class materials, or going and speaking to your teacher to get further support to make sure that you can do the best that you can do in your final assessments and examinations. All that's left for me to do is to wish you the very best of luck with that. And if you found this video useful, do make sure that you're checking out the other support videos available on the YouTube channel here to make sure that you're doing as well as you possibly can and you get the very best grade that you deserve. Good luck, and thank you very much.